Welcome to Amateur Redneck Workshop. I'm Harold, and considering I had a viewer comment the other day, it took me 5 minutes to get down to doing anything. Today we're going to try to cut down to 4 minutes before I get down to doing anything. So we're going to go right on ahead with our amendment of the week. Okay, so today's constitutional amendment is the Third Amendment, and this may not be of interest to people that are not U.S. citizens, and probably not of much interest to a lot of U.S. citizens, but I'm going through the first 10 amendments anyway. The Third Amendment of the Constitution says, "No soldier shall in time of peace be quartered in any house without the consent of the owner, nor in time of war, but in a manner to be prescribed by law." Well, we have a lot of fighting and squabbling over what various and sundry amendments mean, but believe it or not, nobody pays much attention anymore to the Third Amendment. And here's an article by Gordon S. Wood. He says, "The Third Amendment seems to have no direct constitutional relevance at present. Indeed, not only is it the least litigated amendment in the Bill of Rights, but the Supreme Court has never decided a case on the basis of it." So, that the problem, I guess, is pretty much solved by the Third Amendment itself. The federal government today is not likely to ask people to house soldiers in their homes, even in time of war. Nevertheless, the amendment has some modern implications. It suggests the individual's right of domestic privacy, that people are protected from governmental intrusion into their homes, and it is the only part of the Constitution that deals directly with a relationship between the rights of individuals and the military in both peace and war. Rights that emphasize the importance of civilian control over the armed forces. Some legal scholars have even begun to argue that the amendment might be applied to the government's response to terror attacks and natural disasters and issues involving eminent domain and the militarization of the police. Which brings up the Boston bombing that happened here, I guess a couple of years ago now, where they shut down the whole town and went and searched people's houses with no search warrants or anything. They just pretty much did whatever they felt like, and that was basically, in my eyes, terribly mishandled and totally illegal, And all that shutting down the city and searching didn't do them any good anyway, because it was a private citizen that called them up and told them where to find the guy they were looking for. So they cost millions of dollars to the merchants shutting down the town. They cost millions of dollars to people that couldn't go to work. And they definitely infringed on the right to, have a search warrant before you come into somebody's house. So I guess the Third Amendment's a lot more important than any of us give it credit for. And that's the end of that for today, the Third Amendment. So thank you. When I was, let's zoom in. Let me stop that. When I first started in the evil polluting chemical plant, I had one particular job where I was pumping a bunch of evil polluting material through a 1-inch pipe. And it took practically forever, and I told the boss there, who was a learned gentleman, I said, "Look here, can we get a 2-inch pipe installed there so I can pump twice as much evil pollutant through it?" He says, "Well," he says, "it don't work like that, kid." I said, "What do you mean?" He says, "Well, a 2-inch pipe will pump more than twice as much evil pollutant as a 1-inch pipe." And I said, "Really?" And he started to show me all about how, because he had one of those fancy reverse Polish calculators that I guess you put in the answer and then it figures out the question. I'm not sure what's reversed there, but anyway, he showed me a bunch of figures, and I'm going to show them to you. But before I get that for you, you'd probably like to know what got me off on this tangent. I just got back from the metal supermarket. I bought a 1-inch bar of aluminum a foot long, and I bought a 2-inch bar of aluminum a foot long. And a 1-inch bar cost me about $8.50. And the 2-inch bar cost me about $21 and some odd cents. And you'd say, well, if you're just getting twice as big a bar, it shouldn't have cost you $16. So I thought, well, you know, of course, when you look at them, you can kind of see something, but I was thinking about that, and as to how much aluminum did I really get? Did I get 3 times as much aluminum, or did I get twice as much, or what? And that's what got me off on this tangent here, and the pipe was what reminded me of how to calculate it. So now then, we'll go on with the whole thing here. All right, so if you're going to calculate this kind of thing, what you want is you got to know the radius. You know, that's important. And you got to know the height. And a pipe's just like a cylinder. You stand it on end, it's the cylinder standing on end, and if you lay it down, it's the cylinder laying down, and all that sort of thing. But anyway, we need to know the radius and the height and how much pi. And I usually need to take 2 slices, but anyway, we have to figure out the area of a 1-inch circle and the area of a 2-inch circle. Well, the area of the 2-inch circle is about 3 times as big as the 1-inch circle. So then you got to think, well, how much did I really get? Well, the fact of the matter is that in the weight of the aluminum there, I got 9/10 of a pound in the 1-inch stuff, and I got 3.5 pounds in the 2-incher. So I got more than 3 times the aluminum, but I paid less than 3 times as much for it. So that's coming over here, and we see the volume of a cylinder. The 1-inch cylinder's got 9 cubic inches in it, but the 2-inch cylinder's got 37 cubic inches. And again, that's more than 3 times as much aluminum, or at least 3 times as much aluminum. So I think I got a pretty good deal, in as much as if I was figuring 3 times, I should have maybe paid $24 for the 2-inch instead of 21. And it really looks obvious when you set them up there side by side. Well, they don't want to sit side by side real even. There we go. And you look at them side by side there. The one on the left is a 1-inch and the one on the right is a 2-inch. And I know it doesn't look like it could be possible, but it is. I don't know where my square is at. Here it is, right here. There's an inch right there. So that one's an inch, and that one's 2 inches. So amazing, isn't it? And all I did was just double the diameter. All right, well, I'm sure you'd like to do something else now. So this week I didn't make video of me actually doing shop work, but I have done some things. I got more of these little guys here to make different size knobs with. I did one for 1/4 20, and I was going to do one for the number 10 screw, and didn't get around to it. But that was because I was working on changing the way that I put this mold together. In the past, I've had this lid that's set on here, and I put the cylinder of plastic on there and pushed down, and that held everything together. Well, I decided to thread this guy, make a new cap, screw it on here, make a screw in here to screw on the bottom of an injector. Oh, that's right, I forgot to say that. I'm going to make a regular, proper injector for the plastic instead of squeezing it with a hydraulic press. I'm going to take a tube like this, put some heat sleeves on it, although not this heat sleeve. I got this one. This is a 220 volt, and I'm going to use 110 volt sleeves because it makes it easier to plug it in around here. Most all the outlets in here are 110. So anyway, I did this to make sure it would fit. I've got some tubing. I'm going to make a cylinder to go down in there, and I'll weld it all up. Instead of making the support and everything for it, I'll just make a way to bolt it onto the side of my hydraulic press. And anyway, I'm in the process of all that, working with the tubing and waiting for the heat sleeves to come in from China. And in the meantime, though, I've been preparing for the job by I'm preparing for the job by buying something to work with, and this right here is what is commonly known as a PID controller. Okay, I need to back up just a little bit. Alright, so on the left there we've got a relay that's going to be run by this PID controller, and on the right it's a K-type thermocouple that should even serve for melting aluminum and such things. I'll need a little thermal well to put in it, or rather to put it in, but I think I'm pretty well set up for future stuff. The only thing I've got to wait for, like I said, I got to wait for the 3 heat bands to come in from China before I can go on with the rest of the job. Well, I can do part of the job, but that'd be the final part. Now, a PID control, the PID stands for proportional, integral, and derivative. And of course you can make a proportional only controller, an integral only controller, but you wouldn't make a derivative controller because it has to work in conjunction with proportional and integral. I remember when I was doing control work, we had a lot of integral only flows, and they worked perfect. I really liked them, and they would just pull right down to the set point and keep the flow exactly right without a lot of complication. And later on the experts come along and said, no, you need to use proportional, integral, and derivative on all the controls, and that complicated things somewhat, because then you had all manner of calculation and tuning to do to get back to right where you were before they come along with the good advice, really. The way a proportional control works, though, and I'm going to move the camera in closer so that I can talk and point to things and whatever. We'll just move up to here and I'll zoom it back. This is your process value here. It's 87 degrees here in the garage because it's getting close to summer in South Texas. We've been touching on 90 degrees pretty regular. This is the set point value down here. And what happens is when you're below the set point value, this thing will turn on this relay. Right now my set point is too low, so the relay is off. When the relay turns on, this little light comes on here, and this section over here, this is where you put your 120 volts to run the heat bands. But anyway, with a proportional only control, the amount of what you've got is the set point. Say you got 100 degrees for a set point and you're 110 degrees. Well, the proportional control would make a correction in its output equal to the proportion of the error, the 10-degree error from the 100-degree set point, you know. And the bigger the error, the bigger the correction it's going to make. Ordinarily, this kind of control is to control a analog process where, say, you've got steam going into a heating element, a heating vessel, and the steam's heating whatever's in there, and as the temperature goes down below your set point, it increases output to a valve which lets a little more steam in, and it's a continuous thing ordinarily. This is for heat, so with this relay, this is basically an on-off control. If it goes above the set point, it turns off the relay. If it goes below the set point, it turns it back on. So PID, we don't really necessarily need all the proportional or the integral or the derivative. Just integral would do the job here, I think. But anyway, we'll see how it all works out. And this little booger comes from eBay. This is about a $30 item. Comes with the thermocouple and the relay. And I just blew up this part of the instructions that go with it. It tells you how to set it and what all the parameters look like. And it's still kind of hard for me to get the set point on there because somehow I missed the spot where you do that. Anyway, the reason that I'm threading this is to have a threaded cap on here, and I've tried threading the stupid thing already, the internal thread, and you know, it's not a very deep thread, about a 1/2 inch, and I messed it all up, and because you know, I start threading in and it's already over, even though yeah, I was running the machine slow and everything. And you know, the internal thread was nowhere near as slick as this because I was running so slow. I assume that's why it was, you know, so rough and ragged. So what I've determined is I'll run the lathe in reverse, and I will thread the thing starting on the inside coming out, and I can run it at whatever speed I like. I can really crank the thing up and have it moving on, and it should cut a nice smooth thread coming out of the hole instead of going in it. And for that end, I've ordered a threading tool from Shars. It's already made for that sort of thing, so I don't have to make it. I'm kind of lazy. And this week has been really a busy week. That's why I didn't film anything, or I don't use film, I use digital stuff. But the reason I don't have anything in particular is because the week has been so busy with me doing so many things. I just haven't had time to slow down with the camera. It takes twice or 3 times as long with the camera. But this Sunday I had a really good day. It was bench rest day, and I've probably told you this before, but I'm going to show you again. When you do bench rest shooting, you shoot 3 targets like this. There's 25 bullseyes on this target that count. The numbered ones are the ones that count. The ones along the edge are called sighters. You come down there, you can shoot that to see how it's going to turn out. These on top are sighters, and they don't count for anything. But the way you make your score is to cut this 10 ring, this inner ring here, with your shot. If you cut that ring, then you count 0 points here. You know, you deduct 0 points, so this is 10 points and 10 points and 10 points if you cut the 10 ring. If you obliterate that little dot right there, I'm sure you can see that little dot, maybe, hopefully. If you obliterate that little dot, that counts as an X. So if you shot all these and didn't have any points deducted, and say you got obliterated the little dot, you got 20 X's, and some other guy come along and he shot all these, didn't have any deductions, and he shot 22 X's, he'd still win because he got more X's. You can see that, I mean, this is an X, but it's a little off center. This is not an X because you can see the little dot there. But these both deduct 0 points. They get the whole 10 points for each one of these. Well, this Sunday, I had a good day at the range. This was my first target. I got 246 with 15 X's, and you can see that I did pretty good there. This was my worst target because of this shot right here. All it takes is just one shot to ruin the whole target, and that guy right there, he got me the big deduction and brought my score way down. The next one, things got better. I got 248 but only 7 X's, but still the score is going up. And the last target, I got 249 with 6 X's, and for the first time, probably the first time in my life, I got first place in an unlimited bench rest competition. Now, I've had first place a couple of times before shooting factory manufactured rifles, but this is the first time in the unlimited competition that I got first place, so I was pretty happy with that. Got my entry fee back. That was the prize money. And one of the things that helped me was, like I said, shooting these little sighters down the side every now and then was a good thing for me to do. Let's see, that's the 246. This one here, you can see I was testing as I came down every now and then to see how far off that the wind was going to blow me, and you know, you got parallax to deal with and all kind of other things, so it's a good thing to shoot these sighters that you come down each row. Alright, so I guess that's all you wanted to hear about that, but there's not going to be any watching me machine anything this week because I've been going to the range, and I'm going to keep on because 22 Fun Sunday is coming up. And also we've been kind of busy. The granddaughter decided to buy her first new car, and so she wanted us to accompany her for moral support, and we spent a lot of time driving around and looking at cars and testing things. We got that done. So that's what I did this week. Go to the range, get first place, get this new PID controller and start figuring that out and how to set it up, and ordered some heat bands, and I received some seamless tubing, and as things go along I'm going to get closer to doing a little casting. I got all the stuff ready for casting and I just haven't done it. But we'll get there. I've noticed that I'm starting to gain a reasonable amount more subscribers, and I'm of course, like everybody else, I'm grateful to have subscribers. If I didn't have any, I wouldn't be here, obviously, and the fact that they're increasing is encouraging. So I appreciate you guys watching the video, and if you're not a subscriber, go ahead and subscribe. That'd make me happy. And leave a comment. I notice comments are down a bit, and I really like comments. And till I see you again, you guys just keep on keeping on. See you around. Bye.